Hi, I'm Jim Ledoux, and I'm going to go ahead and start off reviewing some of the things that we covered with this first short-term forecast exercise for the Cheyenne office back on January 27th. The first exercise was looking at all the precipitation forecasting mechanisms that might be in play for the 0 to 6 hour forecast that we have. And so, my favorite procedure for looking at this is the winter precip forcing from the RAP 13. The four panel here starts off with taking a look at the tropopause pressure and the GOES 16 air mass RGB product overlaid behind it. We have the winds as well, so we can see where advections of high pressure are coming into lower pressure, which is a good place to infer vertical motion. And the first place we see that is up here in northern South Dakota, southern North Dakota, where you have flow coming in from high pressure to low pressure. This is an indication that we have ascent, at least in the upper troposphere, and it's certainly not a surprise because the air mass product shows a very large comma head cloud extending out in front of it in through eastern Dakotas into Minnesota. But in addition to that, the air mass product shows a long tail of somewhat lower clouds, but extending off to the northwest into central Montana. And along this region, we can see a sharp gradient between high tropopause heights or low tropopause pressures to the southwest, and conversely, high tropopause pressures, low tropopause heights off to the northeast. And along that gradient, we're going to watch and see how the forecast takes that forward. And you notice we lose the satellite imagery. We're in forecast mode now. But you can see that interface is dropping to the south and it's approaching the Cheyenne area by the end of the forecast period. So there's some indication that the wave is bringing higher tropopause pressures down to the south, and there might be some ascent that's going on because of that, and some advections of higher tropopause pressures there, giving an indication of ascent due to the large scale mid and upper tropospheric wave moving off to the southeast. So that's one thing that we're going to look at. The other one, too, is going to be looking at frontogenesis, and already we can see pretty dramatically that we do have it at 700 millibars by the dark reddish into green shaded regions here. And this front here is representative of a polar front that's slicing off to the south in the wake of this big shortwave, which we see now in the GOES 16 water vapor. Also along this, we have in the dashed white contour, in the dashed white contour, we see regions of low equivalent potential vorticity. It's a geostrophic property, and that's indicative of fairly good instability, either symmetric or upright, but in this case, potentially symmetric. So you can see that overlapping along with the frontogenesis, and we move that forward in time, and we can see that frontogenesis extending off to the south. It's in sections here, as you can see, and some of those sections we see are overlapped with still that instability, the low EPV, as we call it. So that looks like a good candidate as well. And we step back a little bit. Now we're going to take a look at and see if there are any thermal advections. So I'm going to go ahead and step over to here where we have the 650 to 600 millibar temperature and wind vectors overlaid on top of the GOES 16 IR channel, the window IR. That's 10.3 microns. And immediately we see something a little bit different. Not something that implies vertical motion going up, but now potentially vertical motion going the other way, and that is cold advection. So you can see it extensively here behind the front in Montana. And as time goes on, you can see as that front moves down to the south, the cold advection comes with it. And so there's potential for, let's say, a negative contribution to upward vertical motion here because of that. Now we go to the final panel here, which is going to be looking at surface temperature and wind. So I think this is it here. Oops, there we go. And here, this is down the surface. One thing I'm interested in is see if there's any potential upslope. So that's kind of the kicker down below to generating vertical motion in the favorable direction. And we see that there potentially is as we go to the later time periods here after the front passes, we have wind coming out of the north and northwest, which could potentially go upslope, let's say on the Cheyenne Divide, which we see right here, and potentially here. But we don't have easterly component here, so it's not a major upslope event. It might go on the east side of the Front Range here, the Medicine Bow Range or Snowy Mountains. So most of the flow is off to the northwest, and it's forecast to be that way in the evening up till overnight here. So looking at all of this, it's frontal dynamics that's the big thing. Speaking of, so we do have an upper level wave, but really frontogenesis is the big contributor here. We see the forecast precip lining up with it, the cloudiness here, and it goes 16 air mass product, and a little bit of tinge of upslope in the appropriate areas on the west side of the mountains here, and potentially on the Cheyenne Ridge from the northerly winds.